Name is linked list cycle 2. So let's understand the problem. So a linked list is given to us 1, 2, 3, 4, 5 and 6, and all nodes are connected. So the question is saying return as the starting node of the cycle. So in this linked list we can easily figure it out that this is a cycle and this is the starting node of the cycle. So how we can solve it? So let's have a hash set, and we will keep adding nodes on in the hash set. So I will add 1, then I will add 2, then I will add 3, then I will add 4, then I will add 5, then I will add 6, and then when I will add 3, when I will try to add 3, the hash set will return false, since hash set can't have duplicate elements. So there only we will return this node. Let's code it. So I will have a hash set of list node I will have a current node. I will point it to head. Then I will start the iteration. If current not equal to null, I will add this current into the hash set. And if it is returning false, it means it is a duplicate node. So straight away we will return that node. Otherwise, I will move the current pointer to next node, and at last I will return null. So let's run it. So it got accepted. Let's submit it as well. So it got submitted. So what is the time complexity? So we are iterating n times here. So the time complexity is order of n. And what is the space complexity? Since we are using hash set and adding all the nodes into it, so space complexity will be order of n. And this is our approach 1 using hash set. Now let's move to approach 2. So we have a linked list 1, 2, 3, 4, 5 and 6. All are connected. Now what I will do here, I will create two pointers, slow and fast, and point it to head initially. Then I will move slow 1 step and I will move fast 2 steps. So slow will take 1 step and fast will take 2 steps. Then slow will take 1 step, slow and fast will take 2 steps. Then slow will take 1 step, fast will take 2 steps. Then slow will take 1 step and then fast will take 2 steps. And then what we are saying, slow and fast came on the same node, and this will happen only when there is a cycle, and the slow and fast pointer will stuck somewhere within a cycle. Okay, then now what we can do, we will have a p1 pointer which is starting from the head node, and we will have a p2 pointer which is starting from here, and then we will move both these pointers together. I will move p2 also. So both this p1 and p2 will move together, and they will move together until p1 and p2 will become equal. So here p1 and p2 are becoming equal. So that then we will return this node. This will be our answer. Now let's code it. So let's erase this. So if head is equal to null, then we can straight away return null. There is no cycle. Otherwise, I will have a slow pointer pointing to head. I will have a fast pointer pointing to head. So while fast dot next not equal to null, and fast dot next not equal to null, I will move slow and fast pointer. Slow with 1 step and fast with 2 steps. Okay. Now I will have a boolean here also. Boolean is cycle equal to false. So if slow is becoming equal to fast, then I will initialize is cycle to true. It means we got a cycle, and then we will break it. So after the while loop, if the is cycle is still false, it means we don't have a cycle. So we will straight away return null. Otherwise, I will create a p1 pointer and point it to head, and I will have a p2 pointer pointing to slow, and I will move both these pointers until they are not becoming equal. So p1 will take 1 step and p2 will take 1 step, and loop will break when p1 will become equal to p2. So we can return here either p1 or p2. So I will return p1 here. So now let's run it. So it got accepted. Let's submit it as well. So it got submitted. Now we will understand the time complexity. So what is the time complexity of this first while loop? Let's understand it. So we have a linked list 1, 2, 3, 4, 5 and 6, all are connected. We are having a slow and fast pointer, and slow is taking 1 step, fast is taking 2 steps. Slow is taking 1 step, fast is taking 2 steps. Then slow is taking 1 step, fast is taking 2 steps. Then slow is taking 1 step and fast is taking 2 steps. And here we are creating a P1 also, but P1 we are creating the while loop. We will see it later. So in the first while loop, so there are n elements are here. Let's count how many steps fast has taken. So this is the first step of fast, this is the second step, this is the third step, and this is the fourth step. So fast has taken 4 steps, which is approximately equal to n by 2 plus 1. So the time complexity of first while loop is n. And for the second while loop, so this is our second while loop. So for the second while loop, what we are doing, we are having a p1 pointer here, p2 pointer here and p1 pointer here, and both are moving at the same time. Okay, so in this example, p2 is here, but with other inputs p2 could be anywhere within the cycle. So let's consider the length of the cycle is k. So p2 can move p2 can take k steps at max. So the time complexity of second while loop is k. So if we are adding time complexity of both while loops, it will be order of n plus k. Okay, so the time complexity is order of n plus k, and space complexity will be order of 1 only, since we are not using any space. And this was our approach to using slow and fast pointers. I hope you have learned something. Thanks for watching.